All right, this is a very big part of the Cessna 310 annual, the swinging of the landing gear. This is why owning and maintaining these things costs so much money. The gear on the 310, as soon as I get this breakfast burrito down, the gear on the 310 can be the Achilles heel of the design. It's a tall, lanky gear, and it needs to be maintained every year to the correct specifications that's in the maintenance book and checked every year so that the gear works properly. Two things can kill a 310. One is beating them to death as a multi-engine trainer, and two, lack of maintenance of the landing gear. And before you know it, it's usually something like the nose gear fails, one of the landing gear fails, gear up landing, and the aircraft is basically totaled because it costs more to repair than it's worth. Stay tuned. Here's our source material for the gear rigging check. The service manual for the 310C and a gear flap system 300 series manual prepared by Sierra Mountain Aviation, Dan Grass, the AI, who's overseeing all our work. If you turn to section 2, 315, we've got rigging of the main landing gear. Step-by-step detail. I just love these old manuals. They really explain well how to properly maintain these aircraft. And then we'll also be using this checklist that Dan's developed over the years to check all the important specifications of the rigging of the gear. Then we're going to lube all the points of contact. Jordan's trying to explain this to me, but it's easier if she just tells us. What's the grease we want to use on the landing gear for the 310?
So usually people use Aeroshell 5, but we like to use the Mobile SHX 100. You could get it on Spruce. It's a red grease. It's great.
That's for the wheel bearings.
Yes.
Now what about for the landing gear on the Cessna 310?
So the landing gear, you want to follow the maintenance manual for the aircraft, and for the 310, it's going to be the Aeroshell number 5.
Okay, so I look for the grease gun with the big number 5 on it?
Yep.
Okay, let's go find it. There it is, Aeroshell number 5. So now we want to take the nose gear out of the whole system by disconnecting it right here. And so now we can, the nose gear can just swing freely here because we got to check the main gear, right? That's what the next objective is, to get all the specs on the main gear.
Correct.
And take the nose gear out of the equation.
Yes. Okay, stop. Okay, perfect. Turn the power off.
Now we can get access to these inboard gear doors. So we want all these gear doors disconnected for this test, including the inboard ones. Now we're going to disconnect the main gear leg right here and drop this wheel. So this is the drop test. Would this be like a gravity type of situation, or it's part of the spec of the whole rigging of the gear? So pull it out, what, 6 inches?
Correct. We just want to ensure it's free. It's going to fall and lock by itself.
Okay. You see how that snapped over center? Just like that.
And you're good.
Try a drop test on the right main gear, again by disconnecting it right up here. And it snaps right into position. So that tells you that everything is free and clear and moving correctly, and the over center is working correctly. We're going to add some external power here to help keep the batteries juiced up while we run the gear. Time to check the up limit switches, and what are those specs? 3/4 to 1.5 turns acceptable, 1.5 desired. Up limit switches. Okay, this next test ensures that the gear stops before it hits the internal stop inside the gear bell crank mechanism there. So right there, Dan, if you could point to that, is the up limit switch. So we want to ensure that the up limit switch is actuated before you get to the full travel of this gear bell crank system, and you want to ensure that it's 1.5 turns before the end of the mechanical portion of the gearing of the bell crank system. Right there again, we're using the landing gear circuit breaker to actuate the system on and off. So now it's just touching the Uplock switch. Now we want to check it with the manual gear extension. So you should be able to crank it up another 1.5 turns before you hit the end of the mechanical stop.
That's 1.
In the bell crank.
And just past 1.
Just past 1. Is that within range?
Correct. We're allowed 3/4 to 1.5.
So we're in range there. Good. So that prevents over jamming the gear system inside the gear bell crank.
Left, right, throttle horns, and then we're going to go down and check the down.
Right there. Okay. And again, this emergency gear extension is just that, a gear extension. You do not use the emergency gear extension to raise the gear. If you have a problem with your landing gear, always remember a down gear is a happy gear. You don't need to emergency raise your landing gear. This is only done for rigging purposes. Okay, now we're going to check for 2 turns on the down side. You just hear the gear down limit switch click, and now
there.
Dan's going to go 1
and
2.
Yeah.
1 and almost 2 within specs. So when you do the emergency extension on your gear, you're going to rotate that thing until it stops. You're going to hit the mechanical limit of the gearbox, and you're going to back it up with a gear light that the gear is down and locked in the event of an emergency extension. In the event of an actual landing gear emergency, always consult your pilot operating handbook, and it'll step you through step by step how to deal with a manual extension on your landing gear. Remember too, on this model of 310, you have a single green gear down light. You have to have all 3 gear switches actuated before you get the 1 single gear down light indication.
Just put my finger there and we pull. We're gonna look for pounds. It's all right at 20.
There, it starts moving.
It moves it.
And
down.
20 pounds is the limit. So let's see that special tool you got there, Dan. So you need this special tool that's going to go on this arm here, and we're going to check the we're going to check the tension to see how much it takes. Make sure that the gearbox is not bound up. And it should take about 20 pounds of spring pressure to just move this lever off of that stop right there, which will ensure that the gearbox is operating correctly and not binding. So the spec for this test is 25 pounds plus or minus 10 pounds, and they have to be within 10 pounds of each other as well. So we had about 20 pounds, and so we're within spec, plus or minus 10. Now we're going to check the left main, pull 90 degrees off, pull, and 21 to 23 pounds right there. Now, if this is out of adjustment, if it takes too much pressure or not enough pressure to move that arm, you're going to start a can of worms in the rigging department and have to fiddle with this rigging in order to get the tension back into limits. It's a matter of geometry. I mean, I suppose you could check for bound up parts or unlubricated parts, but it's a matter of the geometry of the gear that determines these tensions. So this series of tension tests were done in the gear down position. Now we got to repeat this test in the gear up position. So now we're going to move the gear to the up position. Remember, the gear is disconnected, and that's the lever arm that actuates this door right here. You see how that worked? To open the door and then turn around and close it. So now we're in the gear up position, and we're going to recheck this tension. Very clever design.
We're 19.
19?
Yeah.
All right, 19 on the tension in the gear up position. On the left gear. Right gear in the gear up position, 25 pounds plus or minus 10. What do you got there?
25.
25. Perfect. Whew. Next, we're going to check the uplock drop-off. These are the uplocks that the gear rests on in flight, and that grabs this pin right here, and that's what holds the gear up in flight. But we're going to disconnect these uplocks, and we're going to see just how far the gear sags on its own without being held up by the uplocks, so that the rigging on that is correct, so that you're not putting an excessive load on the gear uplocks. Now this next bit I want to dedicate to my friend Jimmy Webb there of Save the 310 Jimmy's World. If you start from scratch on one of these 310s rigging this landing gear, it is at least a 3-day job, and it is a hell of a geometric puzzle to try to figure out all the rigging on this gear to meet all these specifications. And I'm not even sure where you would start on that rigging process other than in pieces. Now before we do the gear uplock test, we got to reconnect the main landing gear. Note of caution, you always want to operate this gearbox symmetrically. You never want to operate the gearbox with the load of one gear on it and the one gear off of it. You'll break it. So we reconnect the gear right back here. And you got to have this gear in this one sweet spot to get this bolt in and out of here to clear that bell crank. Now this is perhaps the most delicate part of the operation. These uplocks, we need to move them just that much. I mean, there's the mark of the original alignment. Loosen these two bolts up. They've just got a little flush Phillips on the backside. Move this uplock down just that much so that it will miss the pin altogether, and we can see how far the gear drops in the full up position without the assistance of the gear uplocks. It's very easy to bend these aluminum uplock arms during this operation. And then of course we'll need to put this back into the correct position for the uplocks to work correctly once we're done with the test. So now with the gear in the up position, we're looking way up here at the uplocks right there. You see how they're clear of the pin? So the gear is just being held up under its own right now without the assistance of the uplocks. So how many times have you heard of a gear emergency where the guy can't get the gear down because he can't get the gear released from the uplocks? This is why it's critical that the uplocks be properly adjusted, especially on a mechanical landing gear system like the 310. Hydraulic landing gear systems are considerably easier to work with than mechanical systems. On a mechanical system, everything's got to be adjusted just right. So the spec for this next test is only 1/8 to 1/4 of an inch of main gear drop off without the assistance of the uplocks. So we've taped a ruler up in the wheel well, just some sort of a reference to see how far this thing's going to drop off once we cycle the gear. We've got our indicator taped firmly into position for the measurement.
All right, so put the handle in that position. Stow the handle, and then put the gear handle in that position.
Emergency handle is stowed, circuit breaker is still pulled, gear handle is now in the up position.
Okay. All right, so we're gonna watch this where it stops roughly when it was all the way up before it was right on the 6 mark.
Okay.
And then when we went down, it raised up and went down. So we're gonna mentally note where it stops up here and then drops
From the high point to where it rests. All right.
Correct. So, all right. So Jordan, you're ready to go up. Go ahead and push the circuit breaker in.
Okay.
And just let it run.
All right. So gear handle stowed, emergency handle, gear handle up. I'm pushing the circuit breaker in.
Correct.
Okay, here we go.
Oh yeah. I saw, what did I see there? 1/4 of an inch or 1/8 of an inch?
Those are, yeah. So we were just over
1/8 of an inch.
Yeah.
Perfect. 1/8 to 1/4. Now, if any of these rigging adjustments are out of spec, go to the book and it'll tell you exactly what you need to adjust to bring it back into spec. But remember, whatever you do on one side of this mechanical gear affects the other side of the mechanical gear, so you have to find that happy medium that keeps both sides in spec. So it says here, drop off not okay, go to step 17. Step 17, disconnect the gear again right here, and we shorten this arm length to increase the drop-off. And we do everything in just 1/2 of a turn increments, because a little bit goes a long way on the geometry of this mechanical system. Now we're checking the Downlock tension, 40 to 60 pounds. And let's go. Hold it. 57.5.
Okay.
Yeah. Okay, we've checked the Uplock hook engagement, and now just tightening all that up, so that the main gear doesn't float around up here too much. We tested the drop, but now we want it to hook with the Uplock hook so that it doesn't bang around up here in the wheel well. And also such that it releases when you put the gear down. This would be the gear down indication switch on the right main. Remember, it takes all 3 of these switches to properly indicate the gear down single green light indication in this model of 310. So remember, this inboard gear door is normally closed with the gear down for takeoff performance. So when you go to raise the gear, the first thing that happens is the bell crank pulls this rod in, sucks it in. It moves this arm, which in turn opens this gear door rather quickly, and then continues to pull this arm, which rotates this tube, which then unlocks these uplocks right here, and then this push rod here, as this tube continues to rotate, it pushes over center, the over center lock, and pushes the gear up into the wheel well. And then these uplocks swing down and lock the gear in the up position, and this arm swings back and forth and recloses this door behind the landing gear. And as you know, for single engine performance, it's critical that you get the gear up and reduce all this drag on the Cessna 310, on any light twin. And just the opposite occurs when you go to extend the gear. This push rod starts moving out. This arm does a quick wig wag, opening up this door. The push rod continues to come out, rotate this torque tube, and the first thing that happens here is it unlocks the uplocks, and then the gear begins to extend by pulling this rod forward and pulling the gear down. Okay, onto the nose gear now. Step 22, we found this idler bell crank right here and checked it for play. It's up under the floorboards there. And now onto the rest of the nose gear. Now we're gonna check the over centering of the nose gear. So show us how that works, Dan. And you're just pushing on the nose gear to get that over center. We don't really do a drop test on the nose gear because on this model of 310, the nose gear is kind of slanted forward. So you got to just push it a little bit, which is what the mechanism does. Go.
There.
That's 20?
20, okay. And then what does the book say?
What's the book say?
It says we're going to be 25 plus or minus 10. So we are in the ballpark.
Clear. You keeping up with all this? Up with a red light. Now let's check the uplock tension on the nose gear.
Alright, so you ready? You can read this side.
Want to read which side? Pound side. Okay,
side.
I got my glasses.
And then I don't know, can you see, you want me to watch where it breaks off, or?
Yeah, you call the brake.
Okay. Oh, right.
There's
there.
65.
65. Okay, and we wanted
Book says
75 plus 10 minus 15. So we
Minus
are good.
15. We're good. All right.
All right.
Get to the bottom of this thing yet?
Oh, no.
Good grief. We've been here all day.
This is why.
No wonder these things are so dang expensive.
Usually gear is about a day.
A day just on the gear. Plan on at least a full day, 2 guys rigging the gear. 2 guys or a guy and a girl. Step 31, uplock engagement. So you get up there with a flashlight and a mirror and you just look for daylight through the uplock engagement and versus the pin. Because it's got a spec there, 0.003 to 0.060 inches. Okay, so with the gear handle in the neutral position here and the circuit breaker out, we're going to continue to extend the gear manually. There goes some uplocks. There goes some lunch. And what I'm looking for is at what point does the green light come on. And the interesting thing here is that, well, the green light should come on without the circuit breaker in. Well, it just comes down real easy. It's almost like gravity. If I let go of it, it'll almost start spinning on you. So you got quite a ways to go there, quite a few turns. I'm watching for the green light here. Okay, I just got the green light. Look at that, there's still ways to go. 1, 2, 3, 4, 5, 6. I call it 6.5 turns. Yep. So that's some real important system knowledge to know that you can get the lights without the motor circuit breaker engaged. Just the opposite of the old Bonanza. And then finally, one of the last things to check is the torque links here. What were those specs? Are pretty tight. Out to 0.002. If you twist this tire, these torque links can only move so many thousandths. And we'll get that tightened up as they loosen up over the years to minimize that. So just one hole tighter on the castellated nut. Tight tolerances on the Cessna 310. Everything that doesn't have a Zerk fitting but moves, you can give it a blast with this. This is the squat switch here on the left main gear, which prevents you from raising the gear on the ground, and we tested that as well. Okay, we got all that done. Now we're going to run the gear up and down with the doors connected, and we also got to time the gear up and down. There's time limit specifications as needed for single engine emergency type operations, and it was about 10 to 14 seconds for the gear to retract, and there's a time limit for the gear extension as well.
Yeah.
Okay, I'm going down. Green light down.
Okay, and then go all the way up one more time.
Okay, I'm going up.
Okay, hold on a second.
Holding on a second.
Oh yeah, look at that. Nice.
Okay, perfect. Can the red light work that?
10.8 seconds up. A little less time coming down. Spot on, good for another year. What do you think, Jordan? Harvey gear ready to go for another year?
We'll see.
We'll see. What do you mean? You sound like Spirit Airlines. We'll see.